look at convex mirrors. Um, so we're going to have our convex mirror here on our Cartesian plane. And we have our three mathematical equations go along with it. 2f equals c, so 2 times the focal point is equal to the center. 1 over the focal point equals 1 over the distance of the object plus 1 over the distance of the image. And the magnification is equal to the height of the image over the height of the object. It's equal to negative distance of the image over distance of the object. If you're unsure of those formulas, you can pause them and write them down. And if you're unsure of the variables in the formulas, you can pause the video here and kind of take a look at them and write them down. So here's our mirror. It's a spherical mirror, okay? Now, I'm going to actually delete the circle part of it because that can sometimes be a little difficult to see the convex of the mirror, okay? But that was just to show where the center of that mirror would be, and then the focal point is halfway between the mirror and the center. So our image is going to be on this side. This is how far we are from the mirror. So let's say we are at a distance of 3. This is 3 units from the mirror, and the height of our object is 2 units. So our distance of our object is equal to 3 units. The height of our object is 2 units. Okay, so let's just draw our arrays to take a look at what this would look like. And then we can use our math to kind of verify this information. So the first line would be parallel. And then from the mirror, okay, it would actually diverge. It would go back. And really where it's coming from is from the focal point. Okay, so it would hit the mirror here and then head backwards. But that light itself would be coming from the focal point. Okay? The next one would be heading towards the focal point. So it would head towards it. We're just going to bring it back a little. Okay. And it would head towards the focal point, but obviously the mirror gets in the way. And then from there, okay, it would head back parallel. Okay, so we would head back parallel. So obviously these are divergent on this side. Okay, this one here is heading up this way. This one here is heading here. They'll never get closer and closer. But on the other side of the mirror, this is parallel through. Okay, they are converging, and that is where they're converging. And then technically, we should be able to draw a line from here to the center that cuts right through where they diverge. So that's not bad. It's pretty much drawn exactly to where they should be. So let's use our math to verify this. We already know from the first formula that this focal point is 3 because 2 times the focal point is equal to the center, which is 6. So 6 divided by 2 is 3. Good. So we have our first formula. Our second formula is 1 over the focal point, which is 3, is equal to 1 over the distance of the object. Distance of the object is 3. Sorry, actually, and we should show, I wrote that wrong. Technically, our center is at -6, which means our focal point's at -3. So I should correct that. It's at -6, which makes this -3. So we have -3. And this here is 1 over 3 plus the 1 over the distance of the image we were unsure of. Okay, so we have 1 over, or -1 over 3. When we bring the other 1 over 3 over, we get -1 over 3 again. It is equal to 1 over the distance of the image. When we combine these, we get -2 over 3 is equal to 1 over the distance of the image. One way to actually figure this out very, very quickly is we can just flip the equivalent ratios or the equivalent fractions. If I flip this side, I just have to flip this side. And this is a common rule. If you know like sine law, you can carry that out. If you're unsure, you can cross multiply and then isolate. But this works just as well. So we still have negative on this side, 3 over 2. And here we have distance of the image over 1, which is just the distance of the image. So the distance of the image is -3 over 2, which is -1.5. And that looks like where they're kind of converging. That's roughly -1.5. So that worked out pretty good. We have our distance of our image. And then from there, we can work on our second formula. Our second formula being magnification equals the height of the image over the height of the object equal to negative the distance of the image over the distance of the object. So we have the distance of the image, and it's a negative. So we're going to get -3 over 2, or 1.5 if you want as a decimal, divided by the distance of the object, which if you recall was 3. And that we're going to set that equal to figure out what the magnification would be. Now, I technically have we have 2 negatives there. We're going to end up with +3 over 2, and that's going to be divided by the value of 3. We can make 3 a fraction by putting it over 1. And then when you divide fractions, so magnification is equal to, you can just invert the second fraction and multiply. So 3 over 2 multiplied by 1 over 3, which will be equal to 3 over 6. So the magnification is actually a half. So it's actually going to be magnified by a half. Magnification is a half, and our object is 2 units high. It looks like this one is roughly 1 unit high, which makes sense. But we can confirm that again with the height of the object over the height of the image over the height of the object. So height of the image over the height of the object is equal to, and we've already worked out this this to be 1 over 2. So we'll set it at 1 over 2. And we knew the height of our object to be 2 units. So we have 1 over, height of the image over 2 is equal to 1 over 2. And very clearly from this ratio, the height of the image is equal to 1, which is exactly what we found with our magnification. So, just like our rays showed, the image is negative 1.5 units behind the mirror, and is a magnification of a half, and so it's only 1 high. And this is really the only case with a convex mirror, that being because all of the images will end up between the focal point and the mirror, and they'll always be smaller than the original object unless they're pushed up right against the mirror. Okay, so this is really the case for all of our images with a convex mirror.